Hey, welcome back, Algebra 2 students. Today we're looking at rational word problems 3-21. So the first part is super easy. We're just going to apply the same ideas that we were applying earlier to solve these, but these are literal equations, meaning that they have more than one variable. But we're going to do the same process to solve for our variables. So notice our a is in our denominator. So we said in the last couple lessons that we can multiply by the common denominator through our whole equation. So a and a are canceling out, so we have 6 on the left side, and then on the right side we have a times p. Now when it says to solve for a, we just got to get our a by itself, so we just got to get rid of our p here by dividing by p. So a is equal to 6 over p. Alright, so same concept on the next one. This one we're solving for y. We're going to multiply by y through our equation. So we have 9y equals, well, the y's would cancel on the right side, so we'd have x. And then we just got to divide by our 9. So y equals x over 9 would be our solution there. So super straightforward, super easy. Now let's get into the word problem stuff. So in this word problem, we're talking about dishes. So there are 480 dishes that need to be rinsed. Scott can rinse them in 80 minutes. David can rinse them in 120 minutes. How long would it take if they work together? So the key to these types of problems, we need to find the rates. So if I know that Scott can rinse, so Scott can rinse the whole thing, 480 dishes in 80 minutes, then his rate would be 480 divided by 80, which is going to be 6 dishes per minute. And then David can rinse them in 120 minutes. So David can do all 480 of them in 120 minutes, which means that he washes 4 dishes per minute. Okay, so let's say here that x equals minutes, because that's what we're trying to find, right? How long? So let's say x equals time in minutes. So let's set this up. Well, Scott's going to do 6 dishes per minute. David's going to do 4 dishes per minute, and they have to wash 480 dishes altogether. So this is pretty straightforward here. 6x plus 4x, they're like terms. That's 10x. Then we divide by 10. So x is going to be 480 divided by 10, which is 48 minutes. And it's always good to go back and check, right? So if David can wash the whole thing by himself in 80 minutes, and then, Scott can wash the whole thing in 80 minutes. David can wash the whole thing in 120 minutes. If they're working together, it's got to be significantly less than both of those numbers, right? So just to check that our answer makes sense is good practice here. So again, step 1, we're going to find the rates. This is the total over how many dishes Scott, over the amount of minutes Scott would take to rinse them, and then again for David, total on top, and then the bottom is the number of minutes it would take him just to find our rates. Okay, the second one, this time we're talking about a plane. This one's a little bit different. So we're traveling with the wind. There's another type of problem that talks about traveling in a boat against current and with current, but they work out the same way. So it says a plane has cruising speed of 150 miles per hour in no wind, which is pretty slow. The plane flew 300 miles with the wind. In the same time, it flew 200 miles against the wind. Find the wind speed. Okay, so again, we want to do the rate, right? So for our rate, it's going to be the distance over time. Or in this case, what we can think about it is we're going to find the distance over the speed because our time was the same. So those of you who did science, this is related to this formula. Distance equals rate times time. So what we're doing here is we're trying to find this for time because the time is going to be the same, yeah? So we're going to solve this for time. And you don't have to remember this, but I'm just showing you the process, those of you who are interested. So if we're solving for time here, we just got to divide by r, right? So the time is equal to the distance over the speed or the rate, right? And because we solved it this way, the time is going to be the same for both. So the distance divided by the rate is going to be the same ratio as the distance divided by the rate for the other one. So the first one, the plane flew 300 miles, right, with the wind. So let's say that let x equals wind speed. So we're going to say 150. And then if it's going with the wind, then it's going to be plus w, right? Because the wind is helping the plane. It's going to be going faster than 150 miles per hour. On the second side, this time it only flew 200 miles, and the speed here, well, the cruising speed is 150, but the wind was hurting it, so it's going less than 150 miles an hour. So that's how we're going to set up our equation for both of them. Now we're going to apply that idea that we used before, that we're going to multiply by the least common denominator. So notice that these are slightly different, so we have to multiply by both of them. 150 plus x, 150 minus x. And then when we multiply to the first part, the left-hand side, we get 300. The 150 plus x is going to cancel. We're going to have 150 minus x still. When we multiply the second part, the 150 minus x is going to cancel, so we'd have the 150 plus x. And then from here, all we got to do is distribute. So 300 times 150, that's 1, 2, 3 zeros. And then 3 times 15 is 45. And then minus 300x. On the right side, 200 times 150, that's 3 zeros again. And then 2 times 15 is 30 plus 200x. All right, so let's move our stuff. We usually take the smaller x and move it to the other side. So that gives us 500x. And then while we're at it, we can take our 30,000 and subtract it to get it to the other side. So that's going to be 15,000 equals 500. And then when we divide by 500, we get 30. Okay, so the wind is blowing at 30 miles per hour. Okay, so make sure when you set it up, you do the distance over the rate is equal to the other distance over the rate. Make sure we get the plus and minus part correct. Plus means that it's going faster because the wind is helping it. Minus means the wind, the plane is going slower because the wind is hurting it or it's slowing it down. So once you do that, then it's just like what we've been doing with the solving of the rational equation stuff. This is good practice. All right, good job.